Today, we're going to dive into the fascinating world of blockchain technology. You've probably heard the term thrown around in conversations about cryptocurrencies like Bitcoin or Ethereum, but blockchain is so much more than just the backbone of digital currencies. It's a revolutionary technology that's transforming industries like finance, healthcare, supply chain management, and even voting systems. In this session, we'll break down what blockchain really is, how it works, and why it's considered such a game changer. We'll start by explaining the core concept of a blockchain.
In this digital era, where information reigns supreme and security is of utmost importance, a transformative technology has emerged, reshaping our understanding and management of data, blockchain. Far more than just the foundation of cryptocurrencies, blockchain is a groundbreaking innovation that promises to revolutionize various aspects of our lives. In this video, we'll unravel the complexities of blockchain, presenting it in simple, easy-to-grasp terms. Whether you're a tech enthusiast, a curious beginner, or a visionary entrepreneur, this video will equip you with a clear understanding of blockchain technology, its purpose, capabilities, workings, types, and its promising future. Let's dive in. What is a blockchain? A blockchain is a digital ledger of transactions that is duplicated and distributed across a network of computer systems. The chain is formed because each block references the one before it through these hashes, creating an unbroken sequence of information. In the tech world, this book club could represent a network of people making financial transactions, like Bitcoin, or computers sharing data. The books could be anything of value: money, property, contracts, or even votes in an election. So, a blockchain is a transparent, unchangeable, decentralized digital ledger that records transactions across multiple computers. It's a way to ensure trust, accountability, and security in a world where these qualities are more crucial than ever. In a simple illustration, imagine playing a game of whispers, where a message is passed from one person to another, often becoming distorted by the end. Now, picture a way to ensure the message remains unchanged, no matter how many hands it passes through. That's the essence of blockchain. In its simplest form, a blockchain is like a shared digital diary. Everyone in the group can add entries, but once written, these entries cannot be altered or erased. They're there for everyone to see forever. This diary is not stored in one place, like a library or a single computer. Instead, it's distributed across countless computers worldwide, making it decentralized. Let's consider an example. You and your friends start a book club. To keep track of who has which book, you create a shared document. Every time a book changes hands, both the giver and the receiver make an entry. This way, everyone can see who has which book at any time. If someone falsely claims to have returned a book, the document reveals the truth. This is a basic illustration of how blockchain works. What is the main purpose of a blockchain? The primary purpose of a blockchain is to enable secure, transparent, and tamper-proof transactions in a decentralized manner. It's about fostering trust in an environment where trust is often lacking. Let's break this down. Security asterisk, each transaction on a blockchain is encrypted and linked to the previous one. This chain of transactions is visible to everyone in the network, but altering any transaction requires changing all subsequent ones, a task that's computationally impractical. This makes blockchain highly secure against fraud and tampering. Transparency asterisk, every transaction is visible to all participants, ensuring accountability and making it nearly impossible for anyone to cheat the system. Decentralization asterisk, unlike traditional databases controlled by a single entity, like a bank or government, a blockchain is distributed across multiple computers. This decentralization means no single entity has complete control, making it resistant to censorship and single points of failure. In essence, blockchain's purpose is to provide a secure and transparent way for parties who may not trust each other to agree on the state of a database without needing a trusted intermediary. Whether it's transferring cryptocurrencies, recording property deeds, or tracking goods in a supply chain, blockchain ensures secure, transparent, and efficient transactions. What can a blockchain really do? While often associated with cryptocurrencies, blockchain technology has a wide range of applications that can benefit everyday people in numerous ways. Here's what blockchain can truly achieve. 1. Secure transactions. Blockchain facilitates secure peer-to-peer transactions, eliminating the need for intermediaries like banks. This could mean faster transactions with lower fees, especially beneficial for remittances or sending money overseas. 2. Supply chain transparency. Blockchain can provide transparency in supply chains, allowing consumers to verify the authenticity of products and track their journey from source to store, enabling more ethical purchasing decisions. 3. Digital identity. Blockchain offers a secure way to manage digital identities, simplifying the process of verifying identities online and making services like online banking, e-commerce, and government services safer and more accessible. 4. Voting. Blockchain could create secure, transparent voting systems, reducing the risk of fraud and making it easier for people to vote remotely, potentially increasing voter turnout. 5. Health records. Blockchain could enable secure, interoperable health records, giving individuals more control over their health data and improving the quality of care. 6. Copyright protection. For artists and creators. Blockchain provides a way to register and protect intellectual property rights, ensuring fair compensation for their work. 7. Decentralized finance. DeFi. Blockchain is the backbone of DeFi, which aims to recreate traditional financial systems, like loans or insurance, in a decentralized, transparent manner, offering financial services to the unbanked or underbanked. How blockchain works, step by step. Understanding how blockchain works may seem daunting, but let's break it down into simple steps. 1. Transaction initiation. A user initiates a transaction, which could be sending cryptocurrencies, recording a contract, or casting a vote. 2. Transaction verification. The transaction is verified by a network of computers, nodes, that confirm its details, including the validity of the transaction and the participant's status. 3. Transaction grouping. Once verified, the transaction is grouped with others into a block. Each block has a capacity, and when reached, a new block is created. 4. Block addition. Before adding the block to the chain, it's given a unique cryptographic hash, created from the transaction data. This block also contains the hash of the previous block, linking them together, hence the term blockchain. 5. Consensus. The block is added to the chain after the network reaches a consensus on its validity. This is often achieved through processes like mining, in Bitcoin, or other consensus mechanisms like proof of stake. 6. Completion. Once consensus is reached, the block is added to the chain, and the transaction is complete. The blockchain is updated, and everyone in the network can see the new block and its transactions. Can a blockchain be hacked? While blockchain technology is designed to be secure and tamper-resistant, it's not entirely immune to hacking. However, successfully hacking a blockchain is extremely difficult and requires significant resources. One potential vulnerability is the 51% attack, where a single entity gains control of more than half of the network's mining power, allowing them to manipulate transactions. However, executing such an attack on a large blockchain like Bitcoin is highly unlikely due to the immense computational power required. Another vulnerability lies in smart contracts. If there's a bug in the code, it could be exploited by hackers, as seen in the infamous DAO hack on the Ethereum blockchain in 2016. Additionally, while the blockchain itself may be secure, applications and digital wallets interacting with it can be vulnerable to hacking. The different types of blockchains. Blockchain technology has evolved into several types, each with its own characteristics and use cases. 1. Public blockchains open to anyone. These are decentralized and transparent. Examples include Bitcoin and Ethereum. They offer strong security and transparency, but can be slower and require more computational power. 2. Private blockchains restricted to specific members. These are often used by businesses for internal purposes. They offer more control and faster transactions, but at the cost of some decentralization. An example is Hyperledger Fabric. 3. Consortium blockchains controlled by a group of organizations. These strike a balance between public and private blockchains. They're often used in sectors like banking, where multiple entities maintain a shared blockchain. 4. Hybrid blockchains combining elements of public and private blockchains. These allow for controlled access, while still enabling decentralized verification. An example is DragonChain. Each type has its own advantages and disadvantages, and the choice depends on the specific needs and goals of the users or organizations involved. The future of blockchains and their true potential. The future of blockchain is both promising and provocative. Its potential extends far beyond current applications, poised to disrupt traditional systems in ways we may not yet fully comprehend. 1. Decentralized Internet blockchain could lay the foundation for a decentralized Internet, Web 3.0, where users control their own data and digital identities, shifting power dynamics in the digital world. 2. Token economy as blockchain and cryptocurrencies evolve, we could see the rise of a global token economy, where tokens representing real-world assets, like real estate or art, are traded on blockchain platforms, democratizing access to investment opportunities. 3. AI and blockchain the convergence of blockchain and AI could lead to more transparent, efficient, and secure AI systems, with blockchain providing a tamper-proof record of AI decisions. 4. Quantum threat the advent of quantum computing could pose a threat to blockchain by breaking cryptographic algorithms, driving the development of quantum-resistant blockchains. In conclusion, the future of blockchain is a thrilling journey into the unknown. It holds the promise of a more decentralized, transparent, and equitable world, but it also presents new challenges and controversies. As we navigate this uncharted territory, it's crucial to foster dialogue about the ethical, legal, and societal implications of this revolutionary technology. If you've made it this far, comment below with the word 100% to confirm you've gained valuable knowledge from this video. For more fascinating topics, be sure to check out the recommended videos on your screen. Thanks for watching.